everyone. Today we're going to talk about application of state of matter and chemical equilibrium in pharmacy. This is our group members and this is our lesson outline. Introduction, states of matter in pharmacy, chemical equilibrium in action, and lastly, conclusion. Have you guys ever wondered why insulin is stored in the fridge? How tablet dissolve in our stomach? And why inhaler is project gases? Well, you can find the answer in physical chemistry. Physical chemistry plays a crucial role in how medicine are designed, stored, and delivered. Chemical equilibrium and states of matter determine drug stability, absorption, and overall effectiveness. Examples like insulin refrigeration, tablet dissolution, and pressure inhaler, it all demonstrate how this principle apply in real-life pharmaceutical formulation. So let's explore more about this principle.
Thank you, Lydia. So, in pharmacy, the state of matter, solid, liquid, or gas, determines how fast and how well medicine works. My name is Balkis, and I'll explain how the concept of state of matter is applied in pharmacy with the focus on the freeze drying process. So, first, in solid forms, like tablet, must dissolve in the gastrointestinal fluid before absorption, as the smaller particles dissolve faster, which speeds up their effect. So, in liquid dosage forms, such as syrups and injections, act faster because the drug is already in the solution. So third is gaseous form, like inhalers, require extremely small particles so that the medicine can reach deep into the lung. However, some medicines are freeze-dried. So here's a process called lyophilization, which turns the drug into the stable powder so it can be stored longer and reconstituted only when they're needed. So even at the simplest level, controlling the state of matter affects the speed, site, and effectiveness of a medicine.
Let's move on to chemical equilibrium in drug action. Le Chatelier principles are used in many drug action. These principles state that if a system at equilibrium is subjected to a change in concentration, pressure, or temperature, the system will shift its equilibrium to counteract the change. Moreover, pharmacists use Henderson-Hasselbalch equation to determine how pH changes affect absorption of drug. For example, aspirin in stomach. When aspirin enters the stomach, there are high concentration of H plus ion. According to the Chatelier principle, the equilibrium will shift to the left, which is toward the unionized form. Therefore, unionized form are more favored and increased. This is the reason why aspirin in unionized form absorbs better in our stomach, because it can pass through the membrane of lining stomach.
Now, I will talk about the real cases of pharmacy involving state of matter. Polymorphism is a key issue in pharmaceutical development because different crystalline or amorphous form of a drug, API, which is the active pharmaceutical ingredient, can have different physical properties, including solubility and dissolution rate. A drug therapeutic effectiveness is often linked to its dissolution rate. A metastable polymer may dissolve faster, leading to better absorption, but it's at risk of transforming into the stable polymer over the product shelf. Now, I will give the real-life examples. First, ritonavir. A prominent case involved Abbott Laboratories' antiretroviral drug, Novel. In 1998, a new, less soluble and more stable polymorphic form of the drug unexpectedly emerged during manufacturing. This new form had poor bioavailability, meaning patients could not absorb the correct dosage. Abbott had to withdraw the product from the market and reformulate it, resulting in significant financial losses and a drug shortage. Second, atorvastatin calcium, Lipitor. Pfizer patented specific polymorphic form of atorvastatin, the active ingredient in Lipitor. The most stable and effective form, Form 1, was a key part of their patent strategy, allowing them to extend market exclusivity for several years. Now, I will talk about the real cases of pharmacy involving chemical equilibrium. Chemical equilibrium principle govern how a drug interacts with its environment, from the manufacturing process to its action in the body. Most pharmaceutical products have a limited shelf life because they are slowly and continuously degrading. Formulation scientists must shift the equilibrium to favor the active drug form and minimize the degradation product. Now I will talk about the example of chemical equilibrium in real cases of pharmacy. Aspirin hydrolysis. Aspirin, acetylsalicylic acid, is a classic example. In the presence of moisture, example, from the air or the excipient, it undergoes hydrolysis, a reaction with water to produce salicylic acid and acetic acid. Salicylic acid is the degradation product and can be an irritant. To follow Le Chatelier principle and prevent this, aspirin tablets are packaged in highly moisture-resistant container, like blister packs or tightly sealed bottle with desiccants, and stored in low humidity environment to minimize the concentration of the reactant, which is the water, and keep the equilibrium shifted toward the stable aspirin site.
In summary, physical chemistry play a major role in how medicine behave, and the state of matter will affect the formulation design, dissolution rate, and delivery system. Chemical equilibrium also control the drug stability and absorption inside the body. As a future pharmacist, we should understanding this concept because it helps us to make informed decision in compounding, formulation, storage, and also patient counseling. Thank you.